already from 1 to 47. Here's our Newton's method project. Now, this is worth 10% of your grade. It's already factored into your current grade on Blackboard. So meaning if you're planning on not doing it, you can pretty much just subtract 10 points off. Well, so if you have an A, I don't put number grades up there. If you have an A, right, you would just drop it down to a B, okay? So it's important that you do it, especially if you want the A in the class. We got a little switch up of seats, so anywhere you want, okay? So I know it's like a shock. Someone's in your seat, right? So Newton's method, it's 10 points on your grade. You can do it in a group up to 3 students. So yourself and 2 other students is fine. Yourself and 1 other student is fine. You can work on it yourself, okay? If we take a look at the project files here, there's 2 of them. One is a rubric, a little bit, this was written, I didn't write it actually, so you could find the solutions on the web, but I'm asking in my rubric a little bit more than what you would find on the web. So let's see, Blackboard courses this semester and our class Monday, Wednesday, Friday, and on the sidebar under project. So there's a rubric, right, meaning telling you what you should make sure you include in the answers, and then the instructions. If we take a quick look at the rubric, "30 things, and some of them are silly, of course. Uniform paper, every piece of paper should be the same if you're handing it to me, right? Does that make sense? And I'll always give you paper. On time, it's either on time or it's a 0 anyway, because it's due the day of the final exam. It can be turned in earlier. It can be turned in electronically, right? So, I'm pretty easygoing with that kind of stuff, but has to be done before you take the final exam. I think that's May 8th, Monday. I think our exam is on Monday. I'll double check it in another couple of weeks or so. You really should so read everything, and it tells you what part it's related to, right? And when you include your computer simulations, I'll show you what I want, okay? So you'll see me do this today on Excel. Who are my computer programmers in here? Nice. What languages? C++ right now, C++. So you could choose to do this in C++ if you wanted to, okay? And then you just have to give me some kind of output table, right? Morning. One correction on the test solutions, okay? So for the other document here, and I didn't write this, so it's written in very kind of super nerd language. It reads like it's very complicated, but it really isn't, okay? So you're looking at Newton's method in our book. You're going to go find a Newton's method on YouTube, right? And I'm basically going to do almost the whole project for you. I don't think it should take you more than 4 hours, probably less if you have a group of 3. But you want to make sure that you don't just divide and conquer. You want to make sure that you work on things together, go apart separate and work on things, come back together and make sure everybody's, on the same page with each other. So the first part is just reading, and they're talking about how this particular method came about. It really it's a pure algorithm, computer science algorithm. It's programmed into your calculator. When you press square root of 2 on your calculator, it doesn't have it stored. it calculates it, and up to the number of decimal places that you have your calculator set on, right? Same thing for pi. It doesn't have pi calculated. It doesn't have it stored. It calculates it based on this particular algorithm that we're going to do in the project. So the idea is, I'm trying to find zeros. It's kind of all we've been doing our whole mathematical lives is to find a zero, right? So we're really interested in this point. We want to find out what x value that is, right? And so I'm going to guess. So I'm going to guess here, that's x initial, right? So x sub 0 is the initial guess. And like if I was trying to find pi, what's a good guess? Well, 3.14 is way too good of a guess. What's a good guess? 3, right? Or 3.1 or something like that. But 3.14, that's accurate to 2 decimal places. Of course, our calculator is set to what, 8? What do I get when I type pi? Oh, I got low battery. So when I type pi and hit enter, I get 3.141592654. So 9 decimal places, right? So, but again, and you'll see as we do Newton's method, sometimes it works and sometimes it doesn't. For the things I've mentioned already, it works. So what we do is we take an initial guess and we go up to the function. So this is now x sub 0, f of x sub 0, right? You with me there? F of x sub 0 is the function evaluated at x sub 0, right? At that initial guess. And I draw a tangent line there, and where the tangent line hits is my next guess. That's x sub 1. And then I rinse and repeat. Keep going until I get as close to the answer as I want, or I actually get the answer. Right? Is that making sense? So what do we know about this tangent line? What's the slope of the tangent line? It's algebraic here. I'm asking you for you to say it to me algebraically. Don't tell me 3, right? What's the slope, though? F prime, right? Yes? F prime of what, though? X sub 0, yeah, the initial guess, right? So I guessed a value on the x-axis. I went up to the function, found the point on the function, found the slope of the function, drew the tangent line. Yes, you with me? And then I'm going to find out where it hits on the x-axis, the tangent line, and that's where I start over again, right? This is called an iteration, right? So what's the equation of my tangent line? What's the first letter? Y, thank you. Why? Because I want to know, right? Y. Minus the y that I know. What's the y that I know? F of x sub 0 equals the slope, which is f prime of x sub 0 times the quantity of x minus x sub 0. So a bunch of those things I know. You agree? A bunch of those things I know. Anything with an x sub 0 in it, I know. Right? Because I made the initial guess. I plugged it into the function. I plugged it into the derivative. Yes? What pieces on here don't I know? What variables here that are written down right here do not know? X sub what? No, x sub 0 I know. That was my initial guess. The x and the y. In fact, I know the y. Look at where the y is. Remember, this is giving me the tangent line, and I want x sub 1. So I want to find this guy. This is my x sub 1, and I'm going to change my variables in a second to make it easier. Okay? So that's the one I want, but do I know this value? Say yes. Good. What is it? 0. Beautiful. So I'm going to change some variables, and I'm going to write in my 0. So I've got minus f of x equals f prime of x times the quantity of x next minus x. So notice all my x sub zeros just became an x. I just guessed at a single x value, right? You with me? And so, and then I want to find where my tangent line hits the x-axis. That x I'm calling the next x sub next. That's just my name for it, right? And I wrote in the y value of 0. And so I want to solve this for x sub next, right? So I'm going to divide by f prime. So I get minus f of x over f prime of x. And I'm going to add x to both sides. So I get my x sub next equals x minus f of x over f prime of x, where x is my initial guess. Yes, you with me? So I just basically did part A and B for you in the project. So I still want you to read it. I still want you to write it up as you think you should write it up, right? So part A says, suppose there's a function with a 0, right? Let x0 be your initial guess and write the equation of the line for the tangent, right? So I did all that, yes? And then find that x-intercept, find the x next value. That's what it's saying in part A. Done, I did it all, right? So, and when they're doing part A, they're using x sub 0, x sub 1, etc., right? They're using all this horrible notation. And then in part B says, hey, can you write it for me in a different notation? And so that's part B, right? So all of that is done. So what's kind of cool, though, if you see what's happening here, look at what happens when I drew that tangent line, and then I got my next guess, and then I went up to here, right, and drew my tangent line. And look what's happening to that x-intercept of the tangent line. It's getting closer to my 0. Do you see that? Yeah? So it's going to eventually hit it, unless it runs away, which is part F in the project. There's a couple of cases where it doesn't work. It fails to work. But also let's look at GeoGebra here. This is a stupid name of a website, but geo, like geometry, gebra, like algebra. Some creative genius there, huh? And I go to Newton's method. It helps to spell it correctly. And I like this one by Eric Jacobson. So there's my initial guess. He's using x sub 1 as the first guess, right? And then we draw the tangent line, and then it hits x sub 2, and that's my next guess. And I go up to the curve again, and I show that tangent line. And again, you see how the x-intercepts of the tangent line are getting closer and closer to the actual root, right? And so that's what's happening. Nice. So part C is the first time you're actually doing some calculations, and you're going to use this iteration formula to show that you can find the solution. So it says I have a graph of 1 over x and a graph of 1 plus x cubed, and they intersect at one point when x is positive. And let's just take a look at that on Desmos. So I'm looking for the intersection of y equals 1 over x and y equals 1 plus x cubed. And you can see it intersects twice, right? But they ask for the positive intersection. So if I zoom in on that positive intersection, right, and I can just mouse over it on your calculators, you would hit calculate intersect, right? But on Desmos, you can just see the answer is 0.724, right? So a pretty good guess would be 0.7. A good guess would be 1 or 0.5, right? Anything close is okay, right? And I think the project's asking for 6 decimal places. So you can set your calculator to do this 6 decimal places. You can use Excel and set it for 6 decimal places. If you're coding this in C++, Anyone else a computer programmer in here? So the two of you, if you choose it, you don't have to, okay? But if you choose to do it in C++, again, you can set your round, right, to a certain number of places. I'm sure that's a built-in function. Yeah. So so taking a look at this problem now, I see I want to find 1 over x is equal to 1 plus x cubed, right? Or I want to create a function that has a 0. So meaning I want to create the function f of x is 1 plus x cubed minus 1 over x. And you can see what I did. I just moved everything to one side. And so now one side is equal to 0, and that's the whole point. That's the 0, right? That's the x that will make the whole thing 0. So we want to make this look as pretty as we can, and pretty's in quotes, right? So I get an LCD. I think, what do we get? X to the 4th plus x minus 1 all over x. Agreed? Yeah? So that's the f of x I want to use. If you look at my formula for x next, it was x minus f of x over f prime of x. So I need f prime as well, right? So you should be able to give me f prime here pretty easily. I'm going to use the circled version to get f prime. Help me. 0 plus 3x squared plus 1 over x squared. I'm doing all of those with power rule, right? In my head. Hopefully in Calc 2, you have all these derivatives quick. Everything from Chapter 3 has to be absolutely instant for Calc 2 to go well, okay? And then everything from Chapter 5 should be pretty much memorized as well. But now we want to look at our x next formula with all of this information. I have x minus f of x, right? Which is what? 1 plus, it's my x to the 4th plus x minus 1 over x, right? Divided by my f prime of x. Oh, I should probably get my f prime of x a little bit nicer too. What is that? 3x to the 4th plus 1 all over x squared. You agree? So there's my x next. It looks like I want to clean this up as well, right? So when you do this over, you're showing me all the algebra in your project, right? Clean it up nice. So let's keep going a little bit. So I have x minus x to the 4th plus x minus 1 over x times x squared over 3x to the 4th plus 1. Everybody with me? Good. You see one of my x's cancel, right? X squared over x, yes? And I'm going to distribute this top x in. I'm going to distribute this one left over x here. So I get x to the 5th plus x cubed. I'm sorry, x to the 6th, right? Oh, no, it's a single x. Single x, right? I'm going a little too fast, of course, but as usual. So there it is. And then I want to get one final LCD, right? So I need to multiply that single x by denominator over denominator, right? So I get 3x to the 5th plus x minus x to the 5th minus x squared. I'm distributing plus x all over 3x to the 4th plus 1. So final x sub next for part C, it looks like 2x to the 5th minus x squared plus 2x all over 3x to the 4th plus 1. There it is. So for part C and part D, I'm doing something similar, okay? I'm actually doing part C right now, right? But you should do it over, present it, write it up the way you think is best, right? So I'm going to put this thing is my generator of the next guess, right? So I put an initial guess in, I get an answer out, and then I put that one back in and rinse and repeat, right? So I'm going to put this into Excel. And you'll see I'm going to put X into column A and X next into column B. I'm going to put my first guess, what did I say, 1 or 0.5 or 0.7? I'm going to put my first guess in A2. This is row 1, row 2. You know Excel at all? Yeah. And I'm going to put this formula right here. And so that's going to be equal sign 2 times A2, right? So I'm getting that X value from A2, right? Caret to the 5th minus A2 caret to the 2nd plus 2 times A2. Wrap that in parentheses, divide by wrapped in parentheses 3 times A2 caret 4 plus 1, close parenthesis. So instead of the variable X, I'm using the row, the column and row in Excel, right? So here I go, I'm going to do that. I don't know how close I can, get my view. I wish I could move this thing. Oh, I can do this. So I'm calling this first piece X, and this next row X next. You do whatever you want, right? I can format and paste into Word. You don't have to paste into Word. You can handwrite the table onto your project, right? You don't have to use Word. You don't have to use math editor, math, equation writer. You can do everything by hand. I don't care. I don't want you wasting time doing little stuff that really is kind of a waste, like what I'm doing right now. None of this stuff is imperative to the project, right? So anyway, I'm going to put my initial guess in as a 1, and then here I'm typing in that whole X next formula, which will change every time you do a new function. So in part C is one function, in part D is a separate function, right? I would say don't write over one, just do a new Excel file or a new set of columns and rows. So I'm going to guess 1, and then I'm going to put my X next formula in, which is equals. Remind me, what's my numerator? All right, forget it, I'll do it. 2 times X to the 5th, right? So equals 2 star A2 caret 5, right? So there's 2 times A to the 5th, yes? Oh, I know I need parenthesis on this, so I better start my parenthesis. Help me, what's my second term in the numerator? Minus X squared? What is it? I can't hear you, I'm sorry. I don't have my ears in. Yeah, minus X squared, right? So minus A2 caret 2 plus, don't tell me, 2x plus 2 times A2, close parenthesis, divided by, open parenthesis, I think it's 3x to the 4th plus 1. 3 times A2 caret 4, all plus 1, close parenthesis. So the next guess I got was 0.75. We already knew it's 0.24, right? Pretty damn close. So I go over to A3 and I say, hey, make this what you just got. So make this B2. So there I'm taking that my result and saying, hey, that's my next guess for X. And now I can fill down I just highlight the last cell I did and do Control D, and it will fill down. So highlight and Control D. And look how quick it got the answer. I know it got the answer in the third line because then it repeats over and over. Do you see that? See, the third line is different than the second line, but then the fourth line is the same as the third line, et cetera, et cetera. So that means I'm there. I got there in three tries. If we started with 0.7, so this is nice, I can change my starting value, I get there in 2 tries. Right? Do you see it? How many tries if I start at 2? It's still pretty quick on the 6th line, so 5th try, right? So there it is. That's almost the whole project, right? So, and this is what your calculator is doing when you want to get the value of pi, right? Or square root of 2 or something like that. So looking at the project for part C, right? It says use Newton's method to find the answer for 6 places, right? Part D, they give me the function for the reciprocal of pi. So they say B is pi, and 1 over x would be the reciprocal of pi. Is that agreeable to you? So part D, I say f of x is pi minus 1 over x, right? That's the function I put in. What do I get when I set this equal to 0? Pi minus 1 over x equals 0. Solve for x for me. Well, let's move the 1 over x to the other side and then do reciprocal of both, right? X is 1 over pi. On Excel, if you're doing pi, I believe it is, so for the value of pi, I believe it is equals capital P, capital I, open, close parenthesis, and it gives you the value of pi. I think it's 15 decimal places worth. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9. But I can set it up to 15, I think. So, but equals pi open parenthesis will get you the value of pi on Excel. Of course, equals 1 divided by pi open parens, close parens, there's my reciprocal of pi. So what's a good guess for the reciprocal of pi is 0.3. Yes, you agree? Yeah. So in part D, you're doing that whole process, right, for X next, right, and then going into Excel or using C++ or whatever you want, or your calculator, right? And the important thing is to see in part D, it says, hey, do this twice, once using 0.5 and once using 0.7. One time it will work, one time it won't. So Newton's method doesn't always work. It really depends on your initial guess, okay? So E is probably the trickiest part. How are we feeling about this? It's not too bad, and I'm doing it, most of it, right? So, but it's just you're writing it over, right? Working with hopefully at least one other student. You can work with up to 2 other students. Yes? I'm going to come back to part E in a second, but part F, notice there's 3 parts to part F. If you're doing this alone, just do one of those 3. If you're doing it in a group of 2, just do 2 of the 3, 1 each. If you're doing it in a group of 3, do all 3 parts, 1 each. Right? Does that make sense? And these will all fail. These 3 processes here will fail for Newton's method. And your goal is to describe why. What's happening? Why is it failing? Right? And for part F, I would do the Newton's method, right? And probably include a graph. And like a nice graph, you can go to GeoGebra. Did I shut it down? Yeah, you can go to GeoGebra, search for Newton's method, and find one that you can change the function to your function, right? And then you can just take a screenshot of it or hand draw it. I don't care. Like I said, you don't want to spend a lot of time on nonsense. Get it done. I like to say, dare to be mediocre. Don't sit there and try and make this thing so perfect and take hours and hours on it. Just get it done, okay? Right? You have a life, you have other classes. Yes, you have family, you have things to do, right? So, and again, I saw a group of 3 students do it in 2 hours. And you can ask for help from anyone. You can go find the answers. You can ask me for help, right? You can't cheat on this. Right? Does that make sense? I like to do this because not everybody tests well, right? I hear a couple of you going, oh, hell yeah, that's right. So it's a chance for you to, help your grade a little bit. And again, homework should be a perfect grade, right? Okay, part E is the toughest part because it's all algebraic, no numbers. Don't give me any numbers, okay? You're supposed to show that the error from your first guess gets squared to give you the error for the second guess. All right, so we have to talk about what error is, right? So you probably in pre-algebra you did something called percent error. Right, where you did the actual, how do you spell actual? Yeah, actual minus your guess in absolute value over the actual. Right, so for part E, your actual is 1 over pi, right? So your first error is going to be 1 over pi minus your initial guess over 1 over pi. And make that pretty, meaning completely factored single fraction, right? No fractions within fractions. Your second guess, the error on your second guess, will again be 1 over pi, but minus x next. So meaning the x next that you came up with in part D, right? It'll be pretty complicated, right? And again, divided by 1 over pi. So this piece is your actual iteration function, right, generated in part D, right? And again, make it look pretty, and you'll end up showing that E1 squared is E2. Algebraically, show me that. And if you read the description here, they say relative, right here in the middle of my page here, right? Say the relative error of x sub n, right? Meaning n is 1, first guess, or n is 0, initial guess, whatever. All of that squared. Do you see that on the right side? That's your initial error squared. Will turn out to be your next error. You see it as x sub n plus 1. So if n was 1 to begin with, right, we're at x sub 1, and now on the left side we're at x sub 2. Right? Do you see that? Somebody? Yeah. So you're going to show that the error, and now listen, think about that. The error gets squared. What happens when you square a number? So if it's bigger than 1, it gets really large fast. If I square it, keep squaring it, right? If it's between 0 and 1, where does it go really fast? 0. And don't we want our error to be 0? Don't we want the exact answer, right? So this thing is pretty powerful, showing us if we make the correct initial guess with an error less than 1, right? It's always the error is always positive. So if the error is less than 1, we're going to get there pretty fast. And you saw how quick Excel did it, right? With a bad guess, when I guessed 2, right? It still did it in 6 steps. Pretty quick. Nice, there's the project. This is due the day of the exam. It can be handed in earlier, of course, right? Right? Any questions? You guys already thinking about a possible way to do it with C++? Really? All you need to do is you're going to hand type in the generator. You're not going to do C++ to get your derivative. You're going to do C++ to do the iteration, right? Yeah. And store the iterations, right? Print out the table. You don't have to do it, okay? It's just an option for you. Yep. So again, part E, I think is the trickiest part, but if you are patient with it and take care with it, it'll just magically show up. It really will, right? But you have to think about what you're putting in. You have to make that X next formula easy to work with, right? Cool. There is a piece